229 billion parameters, 256 experts, 19.6K context window. Let that sink in. MiniMax M2.7 is finally open source. And the craziest part, this model participated in its own development. In this video, I'll show you the architecture, the self-evolution system, and how to deploy it. But stay to the end. The M2 star iteration system is how models write themselves now. That part changes everything. Here's the reality. 230 gigabytes, 30 safe tensor shards. You need at minimum 3 H180 GB cards or equivalent NVLink multi-GPU setup. This is not something you're running on a single GPU. Let me break down the architecture. The model specs are fascinating. 62 transformer layers with 372 hidden size. But here's the trick. 48 attention heads, but only 8 key value heads. That's a 6:1 ratio. It's called grouped query attention, and it's how they keep inference memory manageable at this scale. The real story is the mixture of experts architecture. 256 experts per MoE layer, but only 8 are active for any given token. The router scores all 256, picks the top 8, and the token only passes through those FFN blocks. The rest are dormant. As you can see in this diagram, the routing is elegant. Input token comes in, the router scores all 256 experts, selects the top 8, and only those experts do the actual compute. This is why you get 229 billion total parameters, but the active compute per token is a fraction of that. Now here's something unique. Multi-token prediction is baked directly into the architecture. 3 MTP modules with 1 transformer layer each. This is speculative decoding built into the model itself. No external framework needed. For inference, MiniMax recommends temperature 1.0, top P095, top K40. They're running bfloat25, top K40. They're running bfloat26 with FP8 quantization on the weights. This next part is the most important slide of this video. Because this is the story you need to pay attention to, the M2 star iteration system. Humans configure the harness, write the skills and guardrails, set the research goals, then the model runs the loop autonomously. The model reads docs and logs, learns conventions, self-reviews code, chains skills together, generates reports, and updates its own memory. Humans only review and steer at checkpoints. This is not assisted development. This is autonomous development. And here's the kicker. The harness itself was built by an earlier version of M2. 1 engineer, 4 days, 0 human written code. Then an internal M2.7 ran over 100 autonomous rounds, analyzing failure trajectories, modifying the scaffold, running evaluations, and deciding keep or revert. That process alone delivered a 30% performance improvement. So does all this actually work? On SWE-bench Pro, real GitHub issue resolution, M2.7 scored 56.2%. That's very close to Claude Sonnet 4.6, an open source model within 2 points of the best closed models on software engineering. Here's how you deploy it when you have the hardware. SGLang is the recommended framework, not VLLM. Download the model from Hugging Face. Give it time, it's 230 gigs, then launch with tensor parallelism across 4 GPUs. If you're using FP8 quantization, just add the quantization flag and it reduces VRAM pressure significantly. Let me be clear about the requirements. This is enterprise infrastructure. Minimum 3 H180 GB cards with NVLink. 4 GPUs recommended for FP8. The model download alone is 230 gigabytes across 130 safe tensor shards. This is not weekend project territory. Once it's running, you can test inference via Python or curl. Use the OpenAI compatible API endpoint pointed at localhost port 8000 and send your requests. The model responds with the same quality you'd expect from a top-tier closed API. But if you don't have the hardware, you can try M2.7 right now on OpenRouter. Multiple providers are serving this model with the exact same hyperparameters, temperature 1.0, top P0.95, top K40. Go take it for a spin for free. Here's the bottom line. MiniMax M2.7 is a 229 billion parameter mixture of experts model that's self-evolved. It's competitive with the best closed models on coding and agent benchmarks, and it's fully open source under a modified MIT license. The era of models writing themselves is here.